Okay, hi Math 8. Because my Zoom connection is absolutely terrible and you can't actually see anything through my webcam because the internet's so bad, I've decided to have math videos again. Yay! Okay, so we're going to be talking about lesson 6.1 and also 6.2a, which is about relations and functions. So we're starting a new chapter. Go ahead and take a minute to copy down this definition of the word function. If you need to pause the video, I highly suggest that. So a function is any relationship between two or more variables, an input and an output, that have only one output for every input. And I'll show you an example of both a function and not a function. We've already been working with functions quite a bit, although you may not realize it, because in function notation, usually input is noted as x and output is noted as y. So all of that y equals mx plus b stuff that we just finished, that's an example of a linear function. So, for example, if I said y equals 2x plus 6, that is a function. Why is it a function? Well, let's make a chart and find out. So for this particular function, the input is x. So let's say that I chose an input value of 1. If I plug in y equals 2 times 1 plus 6, I'll get out that y equals 8. So I put in 1 for x, that's one input, and I only get out one output, which is y equals 8. The same thing goes for multiple values, including negative values. So if I wanted to plug in, let's say, negative 2 for x, then I would get y is equal to negative 4 plus 6, y is equal to 2. Again, I only got one output, so this one here we're just going to label function, yay! However, let's say that I have this y equals the square root of x. Well, if I put in, let's say I put in 16 for x. So let's make our little chart again here. What happens if we plug in the number x equals 4? We would have to take the square root of 4. So what this is asking us is what number times itself equals 4. The problem with this is your first instinct is to respond 2, because 2 times 2 equals 4. However, negative 2 times negative 2 also equals 4, which means that there would be two outputs for this 2 and negative 2. So another way you might see it written is like this. So you can see here that there is one input, but there's multiple outputs. So if you see a function that looks like this, that's a problem. Okay, this is not a function. So let's just review that real quick. A function has an input and output, but there will only be one output for every input. So 1 becomes 8, 2 becomes negative 2. That's fine. So over here, this is not a function because there's two separate outputs for one input, x equals 4. Okay, so here's another example, and we might have to look at it and say, is this a function? So let's go ahead and look. I see that if I input x as 1, I get out y is 3, when x is 2, y is 5. What happens when I notice that 3 is an output 2 times? Is that a problem? Actually, no. This just means that, well, when x is 1, y is 3. The only problem would be is if I input x as 1, and I got out that y is 3, and somehow 2. So if you see the lines crossing over like that, then that's a problem. But multiple inputs can have the same output, as long as that output is singular. Okay, we're going to move on to our examples, which means that you should probably take a minute to pause this video so you can copy down the notes here before I start. So, a problem might ask you to find the given outputs for the given input values. And this example here is going to use the problem y equals negative 3x plus 2. So you should know from our previous lessons, this could be read as a y-intercept, this here could be read as a slope, but we don't need to worry about that right now. We're just worrying about the factory machine of plugging in a number for x and finding y. So be very careful to note what exactly they're asking for. They're looking for an output, and they're giving you an input. Sometimes it's going to be the other way around, so pay attention to that. They're saying they're giving you an x, and they want to know y. So, for example, when x equals negative 3, we're going to have to substitute negative 3 in to this equation here. So we're going to go ahead and rewrite that. We're going to rewrite y equals negative 3x plus 2. And remember, when we're substituting, we put that in parentheses. From here, we have to make sure that we're doing the correct order of operations, so we do not add negative 3 plus 2. We have to multiply first using PEMDAS. So negative 3 times negative 3 becomes positive 9. And that means that we're going to get y equals 11. So literally, all you have to do is plug in the value that they give you for x and put it in anytime you see x, and then make sure to simplify so that you'll get y equals whatever, and that will be your answer. So let's do another quick example. When x equals negative 5, we're just going to go ahead and plug in x equals 5 for every instance of x that we see in this original equation. So here, instead of writing a negative 3 times negative 3 as we did up here, we're going to plug in y equals negative 3 times 5 plus 2. Okay, and then we're done. Okay, so the other type of problem you're going to run into says find the given input values for the given output values, which means now they're giving you y, and they want you to find x. So the order of operations is slightly different. So in our original equation, y equals negative 3x plus 2, what happens if they say when y equals 10? Now they've given you y, you have to solve for x. So we're going to take our original equation and rewrite it yet again, and we're going to plug in 10 for y. This is going to require SADMAP to get x by itself. So from here, two things are happening to x. It's being multiplied and it's being added. We have to undo the addition first. We're going to get a really gross number. I don't know why I did that. So we'll get 8 is equal to negative 3x. And then we have to divide both sides by negative 3 to get x on its own. And yes, it is okay to get fractions for these answers. Okay, so we'll find that when we put in negative 8 over 3 into this function, we'll get out the y value of 10. So when you're looking for the x value, you're generally going to have to do a little bit more SADMAP work if you're given the x value.